So serverless is appropriate for different types of applications. It really shines the most with innovation, rapid prototyping, minimal viable product, proof of concept, those kind of projects, because you can develop and iterate extremely quickly. You're reducing your development overhead by using these managed services. And the cost is going to be far lower at these kind of numbers, because if you're doing a proof of concept, you're not expecting to have millions of users. They're very low. And so with a serverless solution, you're paying relative to the number of users that you have. And this is also why it's so attractive to startups. Startups, they need to run lean, they need to be careful with their budgets. So having something that costs them as much as ideally the revenue they're getting from users is very attractive. Serverless can also be used in digital transformation projects. So if you have a legacy solution, the first step would be to migrate that to the cloud. You'd run it on a similar server. Then you might spin off certain things into some of the managed services. Usually the first one would be a managed database. That makes the most sense. However, at some point you're going to run into a block where a server-based application just cannot be made more cloud native. There are certain limits on that. And this is where microservices and serverless can become very interesting, because you can start to spin out features from that legacy application into a microservice. And certain features make more sense than others. So if you want to have the more, data intensive features, that can make sense. So media processing, the image processing that we just mentioned, things that can work really well as a serverless microservice. And so as you start spinning out these features from the legacy into microservices, you can start to scale down the server size and make some cost savings. The other advantage is that you're not faced with one big digital transformation effort with a big budget and unpredictable timelines. You're breaking this very challenging task down into much smaller bits, microservice at a time, that you estimate, you get a budget for. Bit by bit, you can then transform that application into something that is truly cloud native. Pipelines are another powerful use of serverless. So automated deployment pipelines make a lot of sense. Video processing, rendering pipelines, all of these are very good use cases for serverless, where you want to effectively start an event, or some event triggers it, and then it goes through the different microservices to perform what it needs to do. And Netflix is a very big user of this type of capability. So when the studio sends Netflix a new TV or a new movie, they have these massive files. This triggers a series of events to create all the different compression levels of those files and add metadata and descriptions and everything else that needs to happen before it appears in Netflix. Websites and sort of small marketing sites and registration forms that we saw in the example, these are all really good use cases for serverless. Because again, you're paying only for what you're utilizing. You can keep the costs low or relevant to the number of people that are using it. And you can easily launch these things and remove them again when they're done. Much less security concerns that you might have with a server and having to manage the overheads of that. Now, when you get to sort of the more bigger projects, right, full large scale cloud applications, internal or external, that might have thousands or hundreds of thousands or millions of users. Serverless can work for this, but it really depends on the project and some of the requirements. But what we typically see is that these kind of solutions end up being hybrid solutions. So a mix of serverless components and server-based components. And again, it really depends on the need of the project. If you're doing things like massive data aggregation, really heavy machine learning efforts, video processing, like pure serverless is not ideal for these kind of workloads. You tend to then revert to containers or servers working together with the overall serverless framework to make that work.